Bismillahirrahmanirrahim. This is first video of your course. The topic is testing of hypothesis. In this video we will cover the testing of hypothesis in terms of definition, in terms of an example, practical example, and in terms of numerical. So I will explain first the definition of the testing of hypothesis. What is the testing of hypothesis? What is the purpose of testing of hypothesis? And when we use the testing of hypothesis. In testing of hypothesis, according to syllabus, we have 8 different topics, but the definition, concepts and steps are same, but we will use different formulas for testing of hypothesis for mean, variance, standard deviation, proportion, etc. So first heading is the testing of hypothesis. This is the definition of the testing of hypothesis. What is the objective of testing of hypothesis? This is the most important thing. So this definition represents the objective of the testing of hypothesis. The object of testing of hypothesis is to determine if an assumption about some characteristic parameter of a population is supported by information obtained from the sample data. The object of testing of hypothesis is to determine if an assumption about the characteristic of a population parameter. And what is the parameter? What is the statistic? I have already explained in previous class. Parameter may be mean, population standard deviation, population variance, proportion, etc. So population value is called parameter value. So we test the population parameter value with the help of sample data, is supported by information obtained from the sample data and sample statistic. For example, we may test the manufacturer's claim that his electric light bulbs have an average life of 1500 hours. Claim depend on the population value, parameter value, standard value, given value. So we may test the claim. What is the claim? The claim is the average life of this production of electric light bulb is 1500 hours for the current population, current production. Similarly, we may test the average weight of a production of a tablet is 2.5 milligram. We may test the average weight of a production. Production may be large, may be small, but we test with the help of sample data of the population. This is the purpose of the testing of hypothesis. Okay. Our tablet is 2.5 milligram. This is the given value, standard value, criteria. This is the general definition. And what is the statistical hypothesis? A statistical hypothesis is a statement about a characteristic, same as characteristic of one or more population. One or more population mean in testing of hypothesis, we can test the population mean, population variance of the one population or two population, three population, and so on. But in this, we will study only one and two population, mean, two population, variance, etc. For more than one population mean, we will use ANOVA, analysis of variance. ANOVA is also the part of the hypothesis, testing of hypothesis. So, what is a statistical hypothesis? A statistical hypothesis is a statement about a characteristic of one or more populations. This statement may or may not be true. May or may not be true. Its validity is checked on the basis of information obtained by sampling from the population. We check a statement about the population, and this statement may not be true. We test this with the help of procedure of the testing of hypothesis. Its validity is checked on the basis of information. How we test? With the help of sampling from the population. So, a statistical hypothesis means a statement. We test the statement may or may not be true on the basis of sample data. So, for this we select the sample from the population. Next definition, the null and alternative hypothesis. May or may not be true means there are two different types of hypothesis. So, a hypothesis that we formulate for the purpose of rejecting. Purpose of rejecting is called a null hypothesis. First we suppose that it is true and then check either it is true or wrong. So, for the purpose of rejecting is called null hypothesis and denoted by H naught. Any hypothesis that is different from the null hypothesis and is set up in parallel to the null hypothesis is called an alternative hypothesis denoted by H1 or HA. For example, if the assumption is that the average weight of a production of a tablet is 2.5 milligram, the hypothesis is formulated as, suppose in previous definition you read this example, similarly we may test average weight of a production of a tablet is 2.5 milligram. So, how we write this statement? If the assumption, suppose hypothesis, hypothesis means assumption, supposition, in Urdu is called mafruza. Weight of production of a tablet is 2.5 milligram. Production means population. So, the hypothesis is formulated as, so this is the population. Population mean represented by mu H naught colon. This is the syntax of the null hypothesis. First we write H naught, then colon. Don't write here equal sign. Mu for mean, average. Assumption indicate null hypothesis. Average mu is equal to. This is means in mathematics we represent by equal sign. We will use all the statement of the condition you have used in probability is, at least, at most, fewer than, less than, more than, etc. If suppose this word is, then we will write here equal sign 2.5 milligram. This is the null hypothesis. So, alternate hypothesis is a parallel setup. If this is equal to, this will be not equal to, is called alternate hypothesis. This notation will be same always, value will be same always, but notation will be different, parallel to this. If this is less than equal to, this will be more than. If this is more than equal to null hypothesis, this will be less than. We write always the equal sign with null hypothesis, separate equal sign, less than equal to, more than equal to. So, procedures which enable us, this procedure, all the procedure of the testing of hypothesis. This is the first and second step of the testing of hypothesis. In this we will use 6 steps. I will define in next heading. Procedure which enable us to decide whether to accept or reject. Either this accept or reject, or to determine whether observed sample differs significantly from expected results. This is the observed result. We will compare this with expected results, are called test of hypothesis or test of significance or rules of decisions. Level of significance will be also used in testing of hypothesis. This is the first and second step, null hypothesis, alternate hypothesis in terms of definition. I will also explain in terms of mathematical notation. Level of significance, alpha. What is the alpha? In testing a given hypothesis, the maximum probability of error or chance of risk is called the level of significance of the test. Suppose if, for example, 0.05 or 5% level of significance is chosen in designing a test of hypothesis, then there are about 5 chances in 100 that we would reject the null hypothesis when it is true. Reject hypothesis when it is true, this is the error. Indicate we are 95% confident that we have made right decision. So, in testing of hypothesis, we suppose or choose different level of significance depend on the requirement. In the field of mathematical sciences, we use or select or choose 5% or 1% level of significance. Level of significance is called probability of error. Probability of error. Okay. Probability of error and probability both are same thing. In terms of probability is called probability. So if you decide or test the hypothesis and suppose the decision is reject null hypothesis, and your decision may be wrong if you take 5%, or you will be 95% confident you have made right decision. So in testing of hypothesis, we suppose that depend on the field of the data. In the field of medical sciences, we take 5% or 1% level of significance. In the field of economics, we choose 10% level of significance. In the field of defense, we choose or select less than 1%, 0.5%. Okay, so depend on requirement. So level of significance is the probability of error in your decision. Your decision may be wrong. Next definition, critical region. This is the next step of the testing of hypothesis. It must be decided before the sample is drawn. Under what circumstances the null hypothesis will be rejected? Okay, it must be decided before the sample is drawn. Under what circumstances the null hypothesis will be rejected? First, we write the null hypothesis according to the requirement, objective of the study, and we choose the level of significance. So with the help of this diagram, you can understand if calculated value observed result of the test statistic is less than or more than the table value expected result of test statistic, we reject the null hypothesis, otherwise accept the null hypothesis. What is the difference between this observed value of observed result of the test statistic, expected result or test statistics. Observed result obtained from the sample data. First we select the sample from the population and then calculate the mean, standard deviation, etc. sample statistic, and then apply the formula of the test statistic. For testing a hypothesis, for mean we use the t-test, for variance we use the chi-square test, f-test, etc. There are different tests, we will study one by one. So after calculating the observed result, is also called calculated value of the test statistic, we find another test statistic value from the table. Table is given in your book, Walpole book, at page number 481. In this table, different values of the level of significance alpha, a degree of freedom, and values are given. We select the table value with the help of level of significance alpha and sample sizes, and then write this expected result table value in this diagram, with this diagram, and this is the graph or diagram of the normal distribution data, normally distributed data, or used for t-test and z-test. You know that this is the bell-shaped curve or symmetrical curve. The graph of the t-test and z-test is the symmetrical, and graph of the chi-square test and f-test non-symmetrical, skewed graph. And you know that this is the center of the symmetrical distribution, and left hand side indicate negative value, right hand side positive values. So maximum range of this will be equal to minus infinity, and right hand side will be positive infinity, minimum value and maximum value. And total area under the curve equal to, in term of probability, 1, in term of percentage, 100%. So level of significance is 5% or 0.05, means out of total 100%, 5% area. And the values may be negative or positive both of the test statistic. If the alternate hypothesis is not equal to means less than and more than, then we draw the diagram like this. This area alpha upon 2, and this area is 5% if you select or choose alpha equal to 5%. We divide the 5% into two equal parts, so this will be equal to 2.5%, this will be 2.5%, or 0.025 or 0.025. This area is the 95%. If the value of alpha is 5%, so this area and this area represent the 5% area, and this is called critical region or rejected region. This is the acceptance region. If the calculated value, observed result, lies in acceptance region, we accept the null hypothesis. If the calculated value lies in this area, this region, or in this region, we will reject the null hypothesis. If we accept the null hypothesis, means population mean is 2.5, not equal to means not equal to 2.5. If null hypothesis means null hypothesis accept lies in the acceptance region, mu will be equal to 2.5. If lies in the rejected region, will be not equal to 2.5. So this is the sketch. I will explain this with the help of an example after this definition. So this graph represents the graph of the t-test or z-test. And what is this two-tailed test? If this alternate hypothesis is less than, is called one tail, only left side, or more than, right hand side will be one tail, not equal to means less than and more than both. So it's called two tail test. If you have only left hand side or right hand side, is called one tail test. So critical region is also called the rejected region. Rejected region. If calculated value lies in the acceptance region, we will accept the null hypothesis. If the calculated value lies in the rejected region, we will reject the null hypothesis. Okay. Now, this is an example, practical example. With the help of this example, you can understand what is the testing of hypothesis, what is the purpose of the testing of hypothesis, what is the objective of the testing of hypothesis, and when we use the testing of hypothesis. Okay, so there are four objectives. You can understand with the help of this example about the testing of hypothesis, purpose, objective, and when we use testing of hypothesis. The concept is same for mean, testing of hypothesis for mean, standard deviation, variance, proportion, etc. So objective is same, purpose is same, procedure is same, method is same. But what is the testing of hypothesis? When we use testing of hypothesis, this is the most important thing. So this is a practical example. Suppose this is a pharmaceutical company, and this company produce a tablet. The weight of the tablet is 2.5 milligram. This is the given weight, the standard weight. We will produce the tablet or production of this weight, and then we will check either the weight of the total population is same as this standard weight or not with the help of testing of hypothesis. So suppose in beginning, in first year of this new company, suppose pharmaceutical company, the production is only 1000 tablet. Total production, total population represented by capital N is 1000. And very small production. You can calculate the weight of all the tablets. Suppose you select first tablet and then calculate weight, second tablet and then calculate the weight. Suppose the weight of the first tablet is 2.5 as it is. Weight of second tablet is 2.4. Third is 2.3. Next is 2.6. Next is suppose the weight of tablet is 2.5 and so on. If you calculate weight of all the tablets, and suppose the weight of the all 1000 tablet range from 2.7 to 2.3, suppose, and then add all the weights of the 1000 tablet and divided by 1000 for average total weight, and suppose the total weight is 2.5 milligram, same as the standard weight. So you can say about this production there is no significant difference because you are calculating the weight of all tablets, not a single, all 1000 tablets, and after 1 year production increased from 1 to 5000. And suppose this is also very small production, you can calculate the weight of individual tablet up to 5000 tablet one by one, and suppose the weight vary from first tablet is suppose 2.3, second 2.4, third tablet weight is 2.6 and so on, and the total weight, add all the weight 5000 weights and divided by 5000, Suppose the total weight, population weight, this mu used for population mean. So this is the population mean, means total mean, because you are calculating all the 5,000 object items. So average weight is 2.4. And suppose that according to criteria or a standard, depend on the tablet also, there is no significant difference, you can say the production is okay, there is no error. And suppose next year production increase from 5,000 to 10,000, and same as this production, you can calculate the weight of all tablet 10,000, and the average weight of all the tablet is 2.6 according to the criteria, requirement, and quality control procedure standard. There is no difference, you can say the production is okay. But after few years, production increase from 10,000 to 100,000, and you cannot calculate. This is the most important thing, listen carefully. Suppose the production is very large, maybe 100,000, 200,000, 10,000, very large production, and you cannot calculate the weight of all the tablets like this. So how you will calculate, how you will check? Either the weight is same as the standard weight or same as the standard criteria or not. So how you will calculate this population mean? Then we use the testing of hypothesis. This is the purpose of the testing of hypothesis. Population is very large, you cannot calculate the population mean. So what is the procedure? So with the help of testing of hypothesis, we can test, not calculate, test. Either the population mean is same as this standard weight or not, mu equal to 2.5 or not. So what is the procedure? This is the purpose. We will apply the testing of hypothesis. What is the procedure of the testing of hypothesis? According to definition, we select the sample and test the characteristic of the population parameter. I have explained in definition. So first we select a part of the population is called sample. The population is homogeneous. We will use the simple random sampling method. Select a sample randomly and then calculate the average weight of the tablet is represented by x bar because it is the sample mean, and then calculate the standard deviation of the collected sample data, standard deviation of the all weights, sample mean, sample standard deviation, and sample size. Substitute in this formula. This is the formula of the t-test. T-test used for testing of hypothesis for mean, population mean or mean when sample size is small. Small means less than equal to 30. So we substitute the sample mean here, x bar, s here, and sample size. And what is this mu? This mu is the given standard weight. Why we substitute this? Because first we substitute as it is this value, and suppose that the population mean is 2.5 milligram, and when we suppose any statement is called null hypothesis. Supposition means hypothesis. Hypothesis means supposition. In Urdu is called mafruza. Suppose that the population mean is 2.5 milligram, then we use in this formula and calculate the t value. This t value is called t calculated value or observed result. And if this is equal to, this will be not equal to, same value 2.5 milligram, and level of significance alpha we suppose 5% probability of error if you select this sample and decision is null hypothesis accept. So this may be wrong with 5% probability of error, because if you select sample from this part, the result may be changed, different. So with probability of error, chance of risk, we test the hypothesis. And with the help of this alpha and degree of freedom, this is the small mu, this is not V, this is the small mu, is equal to n minus 1 sample size minus 1, you will obtain the degree of freedom. Degree of freedom is the possible chance of selection of sample with freedom. So with the help of alpha and mu, we find another t value from the t table given in your book at page number 481. So if you divide this alpha 0.05 by 2, you will obtain 0.025 and substitute here value of n minus 1, and with the help of the degree of freedom and level of significance alpha, you will obtain the another t value. This value may be positive or negative, depends on this notation. This is the most important notation. We select the critical region on the basis of this notation. Not equal to, value will be positive in table, but we will write same value with positive or negative sign. Negative value will be left hand side and positive right hand side. We will write the negative value left hand side, positive right hand side, and check either this t calculated value lies in the acceptance region or rejected region. If the t value, this t value, calculated value, observed result lies in the acceptance region means between this value and this value, then we will accept the null hypothesis. Accept the null hypothesis means the total population mean is 2.5 milligram. If the calculated value lies in this region, rejected region or critical region, then we will reject the null hypothesis. We will reject the null hypothesis means the population mean, this current population mean, we test always current population, not previous population, because we select the sample from the given population or current population. So this result will be used for this data, corresponding population. So if table value, calculated value lies in the rejected region, we will reject the null hypothesis. Reject the null hypothesis means alternate is true. Alternate true means the population mean, this population mean is not equal to 2.5 milligram. So you can reject this production, destroy this production, because the population mean is not equal to 2.5 milligram. But with the help of some criteria, you can also accept. For this, we will study the confidence interval. In confidence interval, we calculate or find the what will be the lower and upper acceptable value. Suppose the value is 2.4, this is acceptable for this population. 2.6 is also acceptable because there is no significant difference. So with the help of control limit, confidence interval, we set the acceptance level, minimum and maximum. But in this testing of hypothesis, we accept or reject. If you have two choice, either accept or reject, then we will apply the testing of hypothesis. If the requirement is the minimum and maximum range of the acceptable limit, then we select or calculate the confidence limit. After testing of hypothesis, we will study testing confidence interval according to the steps or method or procedure. After the testing of hypothesis for mean, we will study the confidence interval for mean. Testing of hypothesis for variance, we will study the confidence interval for variance, etc. and so on. So I think you will understand what is the testing of hypothesis, what is the purpose of the testing of hypothesis. So with the help of sampling data, we test the characteristic of the parameter value or standard value or given value. Okay, now I will explain the steps used in testing of hypothesis. How many steps? There are 6 steps used in testing of hypothesis. So testing of hypothesis for population mean, this is the most important thing, because there are different methods. We will study one by one. So this is the testing of hypothesis for mean when sigma is unknown and n is less than or equal to 30. This is the condition, because if the sigma is known, we use another method, or n is more than 30, we use another method. If both conditions are satisfied, when sigma is unknown and n less than or equal to 30, for testing of hypothesis for mean, we use this statistics method. This test, this is also called t-test, or in general you can say test statistic. So the following 6 steps are used in testing of hypothesis for population mean mu when sigma is unknown. Maybe this sigma or sigma square, sigma means standard deviation, sigma square will be variance, and n is less than or equal to 30. The most important word is and, A-N-D, and. This and this both should be satisfied in given data, given example or numerical. Then we will use this formula. This is the test statistic. In test statistic, we will use the t-test. So first step, null hypothesis. In numerical, we will use the only notation H naught null hypothesis colon mu is equal to mu naught. In general, we write mu naught, but according to the data or value, we will write here the value. Same as this example, the value is 2.5. Alternate hypothesis will be not equal to. If this is equal to, this will be not equal to. If this is less than equal to, it will be this more than. If this is more than equal to, this will be less than. So I will explain this in step number 5th. Third step, level of significance alpha. Fourth step, test statistic. I have already explained sample mean x bar, mu population mean as sample standard deviation, and sample size. You will obtain the observed result from formula. Fifth step, critical region. Critical region depend on this notation. This is the most important notation. If this notation is wrong, this will be wrong. If this notation is wrong, critical region will be wrong. If critical region will be wrong, the value of the test statistics, expected result of the table value will be wrong, and the last step conclusion will be wrong, question will be wrong. Okay, so critical region is also called rejected region. This is the simply notation represent the area. This t is the calculated value obtained from this formula, and this t alpha upon 2 is the table value we will obtain from t-test table. So this table is given in this video. I will explain after few questions this. In this table, page number 481, the values of alpha are given and degree of freedom n-1. We will use these two degree of freedom according to the data, so we will obtain from this. In this table, all the values are positive, but for left hand side we will write negative value, right hand side positive value. Okay, so this notation indicate only area. This condition may or may not be true if t value less than calculated value less than the table value, means lies here, and t greater than t calculated value greater than table value will be lies here. So indicate critical region, we will reject the null hypothesis So this area represents the critical region or rejected region, is also called rejected region. When alternate hypothesis is not equal to, and degree of freedom mu is equal to n minus 1, this is also given here, mu is equal to n minus 1. So with the help of value of alpha and degree of freedom, we will obtain another t value and then write with diagram of the 5% area depends on the level of significance or 1% area. Either the notation is not equal to or less than or more than. If this is not equal to, we will write the table value both sides and then check either this t value less than, if value is less than, will be lies in the rejected region, critical region, or if t value is greater than or positive, will be lies in this region, we will reject the null hypothesis. If t value is greater than instead of less than, greater than means lies in this area, or this t value instead of greater than, less than, positive table value will be lie in this area. So if the condition is opposite, will be lies in the acceptance region, so we will accept the null hypothesis. So this area, this graph, this sketch represent the area of the rejected region or critical region, and this critical region depend on this notation. Now second option of the critical region may be instead of not equal to, alternate hypothesis not equal to, may be less than. If this is less than, will be left hand side only negative value. In this we divide the alpha by 2, 5% area in two parts. Suppose if alpha is 5%, so this indicate on total area 5%, maybe 1%. So 5% or maybe 1% will be left hand side. If this notation is less than, value will be negative. We will find from table value positive, but we will write with negative sign. Third option, this notation may be more than, value will be positive, we will write positive value right hand side and check either this value, calculated value greater than table value, will be lie in the rejected region or critical region. So this area, this notation represent on the area of the critical region. If this t value less than instead of more than, will be lies in this area, we will accept the null hypothesis. So this is also called one tail test, one tail, and this is called two tail test. Okay, so last step, step number 6. First step null hypothesis, second alternate hypothesis, third level of significance, for test statistic. For critical region there are three choices. 6, conclusion. Conclusion in journal we write, if the calculated value lies in the critical region or rejected region, we reject the null hypothesis, otherwise accept the null hypothesis, but we will write according to the question or statement of the question. Suppose the average weight is 2.5 milligram, you accept the null hypothesis, the conclusion will be, we accept the null hypothesis and conclude that the average weight of the production of the tablet is 2.5 milligram. But in general we write this statement. Okay, so there are 6 steps. 6 steps will be included in testing of hypothesis for mean, variance, etc. But the formula will be different, notation will be different. So now we will solve numerical. First question, 9 individuals are chosen at random from a normal population. This is the assumption, the data or population will be normal, either the population is normal or non-normal, and their heights in inches are given 63, 64 and so on. In the light of the data, test the hypothesis. This word indicates this is the question of the test the hypothesis. Test the hypothesis or test the claim, test the population parameter, test the population value, or 100%, any word indicate 100%, indicate null hypothesis, surety, because null hypothesis mean we suppose that mu is this. The 100% surety or surety indicate null hypothesis. In any question null hypothesis may be given, alternate may be given, null and alternate both may be given, or both may be unknown, not given. So we will decide according to the statement or question. So in this video we will solve 2 questions, and then we will solve more questions with different notation, and I will give you some questions for homework. But these words indicate null hypothesis. Test the hypothesis indicate, this is the question of the testing of hypothesis, and indicate the value of the null hypothesis. So after a few questions I will explain in detail. So mean weight of the population is 66 inches using 5% level of significance. So 9 individual means n is equal to 9. But first we write the null hypothesis, alternate hypothesis according to the sequence. So what is the null hypothesis? 9 individual is the sample random, select randomly from normal population. So this is the sample and their heights in inches. This is the sample of the heights. You can calculate the x bar mean of the sample data as standard deviation of the sample data, because we will use x bar and s in formula. In the light of the data, test the hypothesis that the mean height, this mean height indicate the population mean. Mean height of the population is 66 inches. So this is the mu, is means equal to 66 inches. This is the mu population mean. Alpha 5% level of significance. So null hypothesis mu, this word indicate the mean height is 66 inches. Test the hypothesis indicate H naught null hypothesis, population mean mu is 66 inches equal to 66 inches. Alternate is not given in this question, so alternate will be not equal to automatically. Now then calculate mean and standard deviation using the formula of the sample mean. You have done this in frequency distribution. This is the ungrouped data. We will use the formula of the ungrouped data, and in testing of hypothesis we will calculate direct from calculator. I have already explained how we calculate the mean and standard deviation direct from calculator in form D. So you can ask with your colleagues or class fellows, or you can ask in my office, but you have done this in form D, how we calculate the mean and standard deviation from calculator. In testing of hypothesis you have to calculate direct from calculator, because if you calculate using the formula, this will be lengthy and time consuming. So calculate the mean standard deviation from the calculator. Substitute in this formula x bar as mu 66, calculate the value is 1.28, and another value of the test statistics with the help of alpha. Alpha is 5% and notation is not equal to, we will divide by 2.025. Sample size is 9 individual. Degree of freedom will be n-1 8. With the help of 0.025 and 8, the value is plus minus 2.306. Okay, alpha is 0.025. This is the T table, page number 481. Alpha is 0.025 and degree of freedom is 8. Sample size 9 minus 1 8. The value is 2.306. So plus minus 2.306, because notation is not equal to, we will write with negative sign left hand side, right hand side positive value 2.306, same value with positive sign, and check either this value, calculated value, observed result, this is the expected result obtained with the help of degree of freedom and sample size, or level of significance, probability of error. This is the expected result, this is the observed actual result 1.28 t value, t calculated value, and lies between 2.306 and minus 2.006 and lies in the acceptance region. So we will accept the null hypothesis and conclude that. What is the conclusion? Question is, test the hypothesis. The mean height of the population is 66 inches. So we will conclude that the mean height is 66 inches. So the last step, calculated value lies in the acceptance region. We accept the null hypothesis. This is the general statement, and conclusion is conclude that the mean height of the population is 66 inches at 5% level of significance. We also write the level of significance because sometime at 5% level of significance may be accept or 10% may be reject, and so on. Okay, now next question. This is the t table I have already explained, and in next question we will use the 10 sample. Degree of freedom will be 9. Table value at alpha 0.05 divided by 2.025 will be plus minus 2.262. So next question. A certain drug was given to 10 patients. N is the 10. Sample size is 10. Degree of freedom will be n minus 1, 9. Following increment in their blood pressures were observed. This is the data. You can calculate the mean standard deviation. Mean is 2. Standard deviation is 3.74. Show that the data do not indicate that the drug was responsible for these increments. Use 5% level of significance. In this question, null hypothesis and alternate hypothesis both are unknown, not given. So in testing of hypothesis, this is the assumption that the data is normally distributed, and data is normally distributed means the mean of the normal distribution will be equal to 0. So the null hypothesis H naught will be mu is equal to 0, alternate will be not equal to 0. This is the first criteria. If suppose, and second criteria, the statement is the data do not indicate the drug was responsible for these increments. Is also indicate the suppose before drug, before treatment, the value is same, after treatment is same. Suppose if you collect the blood pressure of the patient, before tablet is the suppose 120, and after the treatment, after the drug, same 120. So indicate there is no change. Okay, so the change depend maybe another factors, depend on the another factors. So show that the data do not indicate that the drug was responsible for this. With the help of this statement, you can also write the result is 0. Before treatment 100, 120, after treatment is same. If you subtract before and after value, the result will be equal to 0. 100 minus 100 will be 0. 120 minus 120 will be equal to 0. So due to this reason, this statement you can also write here 0. But in this question, null hypothesis, alternate hypothesis, both are unknown. So how you will decide? This is the question of the testing of hypothesis. This is the most important thing, because with the help of testing of hypothesis, you can check either the change in the data depend on the criteria or treatment, etc. or not. So with the help of testing of hypothesis, you can test either the change in the data before and after is accept or reject. So with the help of testing of hypothesis, we can test before and after value, and we can test the mean of the data. We can add different level of significance. So mean is 0 here because the standard criteria, we suppose that the population is normally distributed, mean will be equal to 0, and this is the mean of the data. You can calculate direct from calculator or formula. Alpha 0.05 will be 0.025 if you divide by 2, and 10, degree of freedom 9, table value will be plus minus 2.262. Apply the formula, you will obtain 1.69. This is the calculated value, and this value is also lies between the lower and upper value of the critical region. We accept the null hypothesis. So calculated value lies in the acceptance region. We accept the null hypothesis and conclude that the drug was not responsible for increments in the blood pressure at 5% level of significance. not responsible, because before and after the result is 0, value is 0, not responsible. So this is the conclusion. Okay, Allah Hafiz.